4171. Test data indicate that ice, snow, or frost having a thickness and roughness similar to medium or coarse sandpaper on the leading edge and upper surface of an airfoil. A. Reduce lift by as much as 50% and increase drag by as much as 50%. B. Increase drag and reduce lift by as much as 25%. C. Reduce lift by as much as 30% and increase drag by 40%. The correct answer is C. Test data indicate that ice, snow, or frost having a thickness and roughness similar to medium or coarse sandpaper on the leading edge and upper surface of an airfoil can reduce lift by as much as 30% and increase drag by as much as 40%. Therefore, option C is the correct choice. The presence of ice, snow, or frost on an airfoil significantly affects its aerodynamic performance. It disrupts the smooth flow of air over the surface, leading to increased drag and reduced lift. The roughness and thickness of the ice or frost contribute to these effects. 4950. During an IF or cross-country flight, you picked up rime icing which you estimate is 1 by 2 inch thick on the leading edge of the wings. You are now below the clouds at 2,000 feet AGL and are approaching your destination airport under VFR. Visibility under the clouds is more than 10 miles. Winds at the destination airport are 8 knots right down the runway, and the surface temperature is 3 degrees Celsius. You decide to A. Use a faster than normal approach and landing speed. B. Approach and land at your normal speed since the ice is not thick enough to have any noticeable effect. C. Fly your approach slower than normal to lessen the wind chill effect and break up the ice. The correct answer is A. Ice will amass unevenly on the plane. It will include weight and drag and diminish push and lift. With ice collections, landing approaches ought to be made with a least wing fold setting and with an included edge of airspeed. Sudden and huge setup and airspeed changes ought to be maintained a strategic distance from. 4151. Why is frost considered hazardous to flight operation? A. Frost changes the basic aerodynamic shape of the airfoil. B. Frost decreases control effectiveness. C. Frost causes early airflow separation resulting in a loss of lift. The correct answer is C. Frost causes early airflow separation resulting in a loss of lift. Frost is considered hazardous to flight operations because it can cause early airflow separation, leading to a loss of lift. When frost accumulates on the wings or other aircraft surfaces, it creates a rough and uneven surface. This disrupts the smooth flow of air over the wings and can cause the airflow to separate prematurely, reducing the lift generated by the wings. The loss of lift can result in a degraded aircraft performance, decreased maneuverability, and an increased risk of stalling. 4151-1. The formation of frost on an airplane wing will cause A. A change in the basic aerodynamic shape of the wing. B. A disruption of the smooth airflow over the wing. C. The airplane to become airborne at a slower speed. The correct answer is B. Frost on an airplane wing will cause a disruption of the smooth airflow over the wing. When frost forms on an airplane wing, it creates a rough and uneven surface. This disrupts the smooth flow of air over the wing, leading to airflow separation and reduced lift. The disruption of the airflow caused by frost can negatively impact the wing's aerodynamic performance and compromise the overall aircraft handling. 4958. When icing is detected, particularly while operating an aircraft without de-icing equipment, the pilot should A. Fly to an area with liquid precipitation. B. Fly to a lower altitude. C. Leave the area of precipitation or go to an altitude where the temperature is above freezing. The correct answer is C. When icing is detected, particularly while operating an aircraft without de-icing equipment, the pilot should leave the area of precipitation or go to an altitude where the temperature is above freezing. Therefore, option C is the correct choice. Icing is a hazardous condition that occurs when supercooled water droplets freeze upon contact with an aircraft. It can significantly impact the aircraft's performance and handling characteristics. When icing is detected, it is crucial for the pilot to take appropriate actions to mitigate the risk.